For number 1, we're finding the area in a normal distribution associated with a specific z-value. And this is covered in section 5.1. You can do it using tables, and I'm going to show how to do it though using technology in Excel, which is a lot quicker. So if we're using the standard normal distribution in a z-value, this is our formula to use, equals norm.s.dist. And so the dot s is for standard normal distribution, where the mean is 0 and the standard deviation is 1. And what we do then is we just insert the z-value and then comma true. And that gives us the left-hand area from that z-value into the left-hand tail of the distribution. And that is what we were looking for in this problem. For number 2, we're also looking for an area of a normal distribution, but notice this time, different than number 1, it's the area between two different z-values here. So what we're going to do is find, just like with number 1, the area from this point all the way into the left-hand tail, but then we need to subtract off this bit here, which will be the area from this other z-value into the left-hand tail. So we're going to have to do a subtraction. So we're going to use the norm.s.dist equation here in Excel, and that gives us the area from that z-value 1.4 all the way into the left-hand tail, and use that same formula, that equal sign in front, and it gives us the area from that other z-value right here into the left-hand tail, and that is what we want to subtract away so that we just have the part in between. So I use cell reference here, A1 minus A2, and you're always going to have a subtraction like that when you're finding the area in between two different z-values. For number 3, we're finding the area to the left of a certain z-value. And for left-hand areas, we use the formula equals norm.s.distribution and just type in the z-value, comma true. And Excel gives us back the left-hand area. For number 4, we're looking for a right-hand area, the area to the right of a specific z-value. And as it explains in section 5.1, the tables, Excel technology, they all tend to give the left-hand areas, so to the left of a specific z-value. But we know the total area under the curve is equal to 1. So if we want to do a right-hand area, we're going to still find the left-hand area, and I'm going to show how to do that in Excel. But then we take 1 minus that answer, and what we'll be left with then is the area to the right-hand side. So in Excel, I'm going to equals norm.s.dist, that z-value in true, and this is going to give me back all the area to the left of that specific z-value. So the area to the right would be 1 minus that answer, and then this is the area to the right of that z-value. In number 5, we're finding the area between two different z-values. And in 5.1, it again discusses the process needed to find the area between two different z-scores. You take that z-score that's further to the right and norm.s.dist with that z-score, comma true, and that gives you the area from that z-score all the way into the left-hand tail of the distribution. And now we're going to need to subtract away the area that's to the left of our other z-score. Use that same formula with the other z-score, and now we're going to need to use subtraction. So A1 minus A2 here, we're taking the area from that first z-score all the way into the tail, and we're subtracting the area from that second z-score all the way into the tail, and what's left then is the area in between the two z-scores. And number 6, we're told that exam scores are normally distributed, and we're given the mean of the distribution and the standard deviation. And we're going to start off by looking at 4 different students and how well they did on the test and finding the z-scores for their test value here. And notice that if what they did on the test was below the mean, they should have a negative z-score. and if how they did on the test was above the mean, then they should have a positive z-score. In 5.1, it reminds us how to find z-scores. And you take that value minus the mean and divide by the standard deviation. And so I'm just doing it for one test score here, one student score. And they got a 13 in this example, which is below the mean of 21.4. So I should expect a negative z value here. So subtract that and take that entire result divided by the standard deviation. And that is the z-score. So use that same formula for each of the student test scores, and you'll get the different z-values. And if any of those z-values, if they're larger than a positive 2 or a negative 2, then it means they are more than 2 standard deviations away from the mean. And if you're more than 2 standard deviations away from the mean, that is an unusual result. So those test scores associated with those z-scores above 2 are unusual test scores. For number 7, we are told we have the standard normal distribution, and we're going to find the probability of being at a certain z-score or even further to the left. And this is just like finding the area from a z-score or even further to the left. We're going to use the formula equals norm.s.dist. Since we have the standard normal distribution, type in that z-score, comma, true, and it gives us the probability of being at that z-score or further to the left. For number 8, we're finding the probability of being in between two z-values. This is just like finding the area between two z-values, which is discussed in 5.1, the area to the left, to the right, or in between two z-values. Start with the z-value that's further to the right, and we're going to do norm.s.dist, type in the z-value in true, and that gives us the probability of being at that z-value or anywhere further left all the way into the tail. And now we're going to subtract away the part from the second z-value further left into the tail. So use that same formula in Excel with the other z-value, and you get the probability from the second z-value down into the tail. And that's what we're going to subtract away. We do our first result minus our second, we'll be left with the probability of being in between the two z-values. For number 9, we're going to find the probability of being greater than or more to the right of a specific z-value. So we'll use norm.s.dist in Excel, enter in that z-value, comma, true. Now that gives us the probability of being at a z-value or even further to the left. Excel's always giving the left-hand probability, and since the entire probability adds up to 1 or 100%, we're going to use 1 minus the chances of being to the left, and that leaves us with the chances then of being to the right. So if this is the probability of being left of our z-value, then 1 minus that is the probability of being to the right of that z-value. For number 10, we're finding the probability of being in between two different z-values. Refer to the steps in 5.1. We're going to need to use subtraction to do this. We start by finding the probability of being at that first z-value or anywhere further to the left, and then we need to subtract away the probability of being to the left of the second z-value. So we get those two probabilities and take that first result and subtract away the second, and that leaves you with the probability of being in between two z-values. For number 11, we're told that a variable is normally distributed. We have the mean and the standard deviation. We want to find the probability of being below a certain value in that distribution. So one way you could approach this is to find the z-value for the given value, which in this case was 82. So I'm going to take 82, subtract the mean, take that result and divide by the standard deviation. And whatever you get for that z-value result, you plug it into norm.s.distribution. And when you plug in the z-value, comma, true, it gives you the probability of being at that result, in this case 82, or further to the left. Or we can use the formula norm.dist in Excel. So this formula does not have the S, and instead of entering z values, you're going to enter in the mean and the standard deviation here. So your data value, comma, the mean, comma, the standard deviation, comma, true. And it will return the same result, the probability of being at that data value or further to the left in the distribution. For number 12, we have a normal distribution. We're told the mean and the standard deviation. We're finding the probability of being at a specific value or further to the right, being greater than a specific value. So I'm going to use the formula norm.dist in Excel here, and you have to enter in the value, the mean, the standard deviation, and true, and that gives you the probability of being at the value or further to the left. So if you want the probability of being to the right, you would do 1 minus the chances of being to the left, and that's the probability of being at a certain value or greater than that, further to the right. For number 13, we're told we have a normal distribution. We're given the mean and the standard deviation, and we're finding the probability of being in between two values. So using our formula norm.dist, we're going to want to enter in our larger value, the mean, the standard deviation, and this gives us the probability of being anywhere to the left of that value. And we want to do the same thing with the smaller value, and that gives us the probability of being to the left of the smaller value. And like we saw in 5.1, you want to take that probability of being anywhere to the left of the first value and subtract away of being to the left of the second value, and you're left with the probability of being in between the two values. So doing the subtraction here, our first result minus the second result leaves us with the probability of being in between the two values. For number 14, we have a scenario here. This example is about SAT scores. We're told it has a normal distribution. We're given the mean and the standard deviation. And first we want to find what percent of the scores are less than 650. So I'll use the formula equals norm.dist, type in that value, the mean, the standard deviation, comma, true, and it gives me the probability of being at that value or anywhere further to the left, anywhere less than. And to write that as a percent, you would slide the decimal 2 spots to the right, which is multiplying by 100. And so it would be 86.88% of the data is to the left of that value you enter in as the first argument. For part B, first we're going to start off by finding the percent that we expect to be greater than the given value here, which in this case is 550. So using equals norm.dist with 550 here, we will get the percent of scores that we expect to be less than 550. So if I do 1 minus that, I'll get the percent of scores that I expect to be greater than 550. And part B is actually phrased to say if we look at 1,000 scores, how many out of those 1,000 would we expect to be greater than 550? So we need to use that percentage we just calculated. So take the percentage of scores that are greater than 550 and multiply it by how many scores we have. In this case, it was 1,000. And you can't have a partial test. There's 1,000 scores. We need to round to the nearest whole value. We're going to round to 377. So we would expect 377 out of the 1,000 scores to be greater than 550.